Hey everybody, welcome to Unit 3, Inequalities. Today we're just going to do a short little introduction into inequalities, simple inequalities, get you guys familiar with those. And then next time, I'm actually not going to be in class, but your favorite classroom assistant, Ari, is actually going to teach you guys about compound equalities. He's got a really great lesson plan in store for you guys, maybe even a fun little game. So, let's just take a few minutes here to talk about simple inequalities. The homework for tonight, as it says on the assignment sheet, is to watch this video, take notes, and to complete the front side of the worksheet, the first 6 problems. Ari's going to check those in next class, as well as collect your weekly review, and then he'll teach you about compound inequalities. Okay, so let's get started. So first of all, we should probably know the different inequality symbols. Okay, now there's a couple, several different symbols. Some you may already be familiar with. I'm going to go ahead and put the 4 main ones down that we're going to work with this unit, and I want you to see if you can recall what they each stand for. Okay, so this first one all the way to the left is, anybody? Anybody? Oh yeah, can't hear each other, can you? Okay, so that's less than. I remember when I learned about less than, my teacher said, hey, put your left hand out. Everybody try it. Come on. And make an L with your pointer finger and your thumb. And if you kind of turn it in a little bit, oh, there's your less than sign. Okay, so pointing to the left is less than, pointing to the right is greater than. Anybody know what it means when you put that bar underneath? It means or equal to. So now we're looking for values that are not just less than, they're or equal to. And this last one on the right would be greater than or equal to. Okay, it's important that you understand the difference between less than and less than equal to and greater than or equal to. Because while solving inequalities is very similar to solving equations, the main difference is that there's going to be a graphing portion, and then sometimes you might have to change the orientation of your symbol. So those are just going to be the 2 new things that we're going to think about. Okay, but so we're going to look at a couple of different examples here, see how they're different from equations, see how they're the same, and there we go. So for each example, we are going to solve each inequality and graph its solution. Now, what I should have started off with is talking about why is it called an inequality versus an equation. Well, in an equation, things are equal, hence the equal in the equation. We have 2 sides equal. And then inequality, you have things that are unequal, right? Something's less than or greater than, less than or equal to, greater than or equal to. Okay, so let's see how that affects our solution. So the first one we're going to look at is -3 plus 2b is less than 13. Okay, so as I said earlier, you are going to solve this just like you would solve any equation, just to start off. Okay, so in the equation, we would get to be alone. So we're going to add 3 to each side. So we have 2b is less than 16. We're going to divide by 2 and get b is less than 8. Okay, so first thing that's different here is we're not saying b equals 8, it's less than 8. When b equals 8, there was one solution, 8. How many solutions do you have if b is less than 8? Well, what are possible things you could fill in place of b? So if I say blank is less than 8, think of all the numbers that you could plug in there. 7, 6, 5, 4, so on and so forth. Okay, so before it was enough to just say, hey, b equals 8 and you were done. Now, because we have infinitely many solutions, it's helpful to have a visual with it. So we're going to draw a number line. Always put this, I call it your border number. You're going to put it right in the middle and put a number to the left and right. Okay, so we want to shade all of the values that are less than 8. Okay, well, the ones that would be less than 8, we said are 7, 6, 5, 4. Okay, so now we're going to shade everything to the left of 8. Whatever you are shading is a solution. That's how you're showing all of the solutions because there's infinitely many. Now, 8 I called a border number earlier. So every time we have one of these, we're going to put a circle there and we have to decide if it's open or closed. What was that? Good one. Let me do this again. Okay, so remember we shade things that are solutions. So if it's a solution, we're going to fill in that circle. So technically it's shaded. If that number is not a solution, we're not going to fill it in. So here's the question to think about. Is 8 less than 8? No. Okay, since it's not, we're going to leave it as an open circle because what that's telling us is, hey, 8 is not a solution. 8 isn't less than 8, but everything to the left of 8 is. 7, technically 7.9, 6, -2, -1 million. Okay, so let's do another example here. In that example, we have m over 6 minus 5 is greater than or equal to -6. Okay, so now we're going to solve this inequality. Again, use the same steps. If you want to pause the video, you can. Use the same steps you would for an equation, and then we're going to graph it. Okay, so we add 5, add 5. So we have m over 6 is greater than or equal to -1. We want m alone, so we multiply each side by 6. And we get m is greater than or equal to -6. Okay, so I'm going to do the same thing here like I did last time. Draw my number line, put my border number, -7, -5. Okay, you got to be careful with the negatives, right? Because remember that your smaller negatives are actually the bigger numbers, -7, -8. Okay, so we want to shade all of the values that are greater than or equal to -6. So where are they greater than? What numbers are bigger than -6? -5, -4, -3. Okay, so we're going to shade to the right. Okay, this time, what's different? Well, this time we want the values that are actually greater than or equal to -6. So when we think about earlier, testing to see if that's a solution, is -6 greater than or equal to -6? Yeah, it's or equal to. So since it's or equal to, at that boundary, we're going to shade it because that's our way of indicating, hey, -6 is a solution. Okay, very good. Now, I know some of you might be thinking, okay, Mrs. Brasher, you're making this a little bit more than it needs to be. If there's a line underneath, I fill in the circle. If there's not, I don't, which is true. But I want you guys to understand the reason why you're filling in the circle is because it's a solution, and that or equal to lets it be a solution. Okay, so we've covered one difference between equations and inequalities, and that's the fact that we're going to have this graphing component. Okay, the other part is just one step in the solving. So we're going to look at 2 examples like that and call it a day. Okay, so example 3 is -52 is less than 8 minus 5. Okay, so we need to solve this inequality. All right, so initially you're still going to do things the same way. It's this -5 that's going to throw us off, and I'll show you why. Okay, so we need to move the 8, so let's subtract the 8. And we get negative 60 is less than negative 5k. Okay, and then we need to move that negative 5. Okay, so we divide by negative 5, and we end up getting 12, and then on this side we have k. Now here's what's going to change. Because we divided both sides by negative, we need to flip the symbol. So if you multiply or divide both sides by a negative number, you have to flip the symbol. Now, a couple of key things here. It has to be both sides that you're multiplying or dividing by a negative number. And the reason why it has to be both sides is because what happens is, notice when you multiply or divide both sides by negative, you change the signs. So here you had negative 60 and negative 5k. Well, think about how these are relating. Negative 60 right now is much smaller. But then when you change their signs, 12 is now bigger and the 1 is smaller. Now, I don't want you to get confused and think, okay, that's why it changes to be greater than versus less than, because this is bigger and smaller. But the idea here is because since dividing or multiplying both sides by a negative changes the sign on each side of the problem, we have to change the orientation of that symbol. So it's no longer less than, but greater than. Okay, so now when I'm going to graph this, I still put my border at the middle. Okay, now careful when you read this. 12 is greater than k. A lot of people think because it's pointing to the right, you're just going to shade to the right. Not necessarily. Think about what you can fill into that blank. 12 is greater than what? You could fill in 11, 10, 9, right? So we're actually shading to the left here, right? Because you're just thinking of what numbers could go in that spot. 13 could not. 12 is not greater than 13. Now, something some students like, because this is a little difficult to think about, is they always like to move the variable to the left. So if you switch the variable over, notice that our sign's pointing to the k, so it should still point to the k. So because I'm switching the side of k and 12, I switch my symbol back again. But now this is k is less than 12. That might be easier to interpret. Okay, last question. Last question for this problem. Open or close boundary on 12? Open. Good. Why? Because it's not a solution, right? We know that 12 is not less than 12. Okay, last example. I'm going to go ahead and put an example down here for you guys to try. I want you to pause the video and give it a shot. Okay, it is negative 9 is less than or equal to negative 8 plus v over negative 6. Negative 9 is less than or equal to negative 8 plus v over negative 6. Okay, so go ahead, pause the video, try it, and then come back and see what you did, how you did. Okay, so I'm going to add 8. Now that you're back with me, negative 1 is less than or equal to v over negative 6. I'm going to multiply each side by negative 6. 6, and v. Now notice I multiplied both sides by negative, so I need to flip my symbol to be greater than. Now if it's helpful, remember we just talked about in the last problem, rewrite this as, since 6 is greater than or equal to v, v is less than or equal to 6. When you graphed it, you should have 6, 5, 7, close boundary on 6 because 6 is a solution. 6 is less than or equal to 6. And all the other numbers that are less than are here. And there you have it. All right, guys, that wraps up simple inequalities. I don't have a Google form for you guys to fill out. You have your worksheet to do. But here's what I do want you guys to do. If you have any questions about this, that's not quite making sense, why don't you, I would like for you to just send me a quick email and just in a sentence or less, you can tell me what part's not quite making sense, because I want to pass on that information to Ari so we know exactly where we're getting started next time. Ideally, if you can come in for help, that's the best thing. But if not, at least just send a quick email saying, I'm having trouble with blank. All right. All right. And have a good night, guys. Bye.